Hey there, guys. We're looking at box and whisker plots today, and we're also going to look at outliers in just a little bit more detail, make that a little bit more official. We've talked about them from the perspective of what they are, but now we're going to look at them from the perspective of identifying them algebraically. So, first of all, before we can get into box and whisker plots themselves, we need to talk about the quartiles. Quartiles, as kind of maybe the name implies, divides this thing into quarters, basically values that divide the data into 4 equal parts. All right. The median is the second quartile. We already know that the median, what the median is, that's the middle data value. And remember, when there's a tie for the middle, we take the average of those two values. Okay. So then if we want to break this thing into 4 pieces, see, the median breaks it into 2 pieces. So then we just have to take each half and break it in half again, and those will be the first and the third quartiles respectively. For example, if I look at this guy, and just like we do with the median, we have to put this thing from least to greatest first. This one's already in order, so we can kind of start counting off from each end until we find that value that's in the middle. And so right here, the value that's in the middle is this guy. It's the 11, so that's the median. Or we could say that's the second quartile. But again, second quartile and median mean the same thing, all right? But now we're going to kind of look at this in 2 chunks. We're going to look at this chunk over here and this chunk over here separately. Well, just like I did before, start counting off from each end. So if I start counting off from each end and find the one in the middle, it's this guy. And so the one in the middle is the 5. That's the first quartile. If I do the same thing over on the other end, start counting off from each end until I find the one that's in the middle, it's this guy. So that is the third quartile. And so again, we're doing the same thing that we did with the median. And you can call it Q2 like it did in the middle, or you can use the little subscripts. That's fine. I'm used to using the subscripts, but it doesn't matter. Okay? So again, we do the same thing we did with the median, but we just have to do it a couple extra times. We find the median of each side then to find the first and the third quartiles. And that's it. Now the data is broken into 4 equal pieces. You can see them. Here's a piece with 2, a piece with 2, a piece with 2, and a piece with 2. And see the 5, the 11, and the 21 are kind of caught in between those 4 pieces. All right? The interquartile range is when we find the difference between the third and the first quartile. So once again, if we start counting off from each end to find the median. And so here the median once again is 11. This is the same example we just did. So the second quartile is 11. And then if we find the middle of each end, we've got the first quartile at 5, and we've got the third quartile at 21. So now the interquartile range, we just take the third quartile and the first quartile and we subtract them. So I do the 21 minus the 5. Let me take that off to the side. 21 minus 5 equals a 16. So the interquartile range is a 16. And that's it. And that's just kind of showing us a little bit about how the data is spread out. Just like when we did the range, is the least to the greatest. All right. The interquartile range is the range between the biggest and smallest quartile. Okay. So now the box and whisker plot kind of uses all of those values. If we look at this guy, once again, it's the same data set. So here's my second quartile is the 11. The first quartile is the 5. And the third quartile is the 21. What we do is when we do a box and whisker plot, we essentially kind of display this thing on a number line. Sorry, I covered up that definition a little too fast. But we're going to create a number line, and then hovering above this number line, we're going to put the box and whisker plot. It's a graph that kind of summarizes the data set using the maximum, the minimum, the quartiles, and just to kind of displaying this as a nice, succinct way. All right. So the quartiles are going to be represented as lines on the graph. The max and minimum are going to be represented by dots, by points. All right. So the first thing I need to do is I need to kind of construct the number line that's going to go underneath this thing. So here's the number line that's going to go underneath this thing. And I kind of want to evenly spread all this stuff. And I got 23 dashes here. Let me extend this a little bit more so I can just go by ones. And you might have to scale this a little bit differently depending on how much space you have. You might have to go by 2s or 3s or 4s or whatever. Just like any time we're graphing something. So then maybe here I'd put this at 0. And each of these represents 1 unit. But I'm only labeling every fifth, just to make it a little easier on myself. And so now I start plotting these. Again, the quartiles, I'm going to plot those each as a line. So the first quartile is at a 5, so I put a line here at 5, just hovering up above this thing. The second quartile is at 11, so I put a line above the 11. The third quartile is at 21, so I put a line above the 21. And then basically that's my box. I can connect this thing and make a box out of it. And then the maximum and minimum, the minimum is here at a 2, and the maximum's up here at a 25. Those are my whiskers, and so I stick lines out to connect those things. All right. And basically all this thing is showing me how condensed or spread out the data is. Like when you look, the same number of data values exists in each of these sections. So each of these 4 sections has the same number of data values. But notice this section looks the biggest, which means in that section the data is the most spread out. In fact, the top end of this thing versus the bottom end of this thing is more spread out. Like when you look at the first 2 sections, here's 50% of my data values right here. And yet that section is a lot smaller in terms of length, which means the data values are a lot closer together when I'm closer to the bottom, to the lower end of these data values, okay? And so that's kind of what this thing is displaying for us, all right? Now let's talk about outliers. We've talked about outliers from the perspective of what they are, but now here's a more official rule for determining whether something should be an outlier. So the outlier rule, a data value is considered an outlier if it is greater than the third quartile by 1.5 times the interquartile range, or less than the first quartile by 1.5 times the interquartile range. In other words, if I take the interquartile range times 1.5, that tells me how far away from the first and third quartile I'm allowed to travel before it's considered an outlier, okay? So again, we do 1.5 times. That tells me how far. So 1.5 times the interquartile range tells me how far from the third quartile I'm allowed to go up, how far from the first quartile I'm allowed to go down before it's considered an outlier. All right. For example, if I look at something like this guy. And again, if we start breaking this data down, this is a little bit different than the last example. So I have to find the median. So I have to identify all the quartiles because I need the interquartile range. And it looks like I've counted 4 on each end. Looks like the median is kind of caught in between these two. So if I found the average of that, that's 11.5. And so that's where this data gets broken up right there. All right, so now I have 5 values on each side. Now I start counting from each end again. So there's my first quartile. And there's my third quartile. Okay, so I'm identifying each of the quartiles. And so now the interquartile range for this one is going to be the 21 minus the 6, which is 15. All right. So 15 is the interquartile range. To determine an outlier, I'm going to take the interquartile range times 1.5. So let me take that off to the side over here. So the interquartile range, which is 15, times 1.5. And if I do that times 1.5, it gives me a 22.5. Essentially what that's saying how far I'm allowed to travel from each quartile before I'm outside the acceptable range. So for example, right here, here's the third quartile. I'm allowed to go from that. I'm allowed to go up 22.5 units and still be in the acceptable range. So if I do the 21 plus 22.5, that gives me a 43.5. So in other words, 43.5 is still in the acceptable range. Anything beyond that would be considered an outlier. The same thing going this way. If I go down 22.5 from that 6, anything below that would be considered an outlier. The 22.5 is as far as I'm allowed to go and still be in the acceptable range. So if I take the 6 minus the 22.5, That's going to give me a 16.5, or negative 16.5 rather. And so basically it's telling me that anything in between, sorry, I should have written that one in green. Anything in between the negative 16.5 and the 43.5 is part of the acceptable range. It wouldn't be considered an outlier. So when asked the question, is 43 an outlier? Well, is that in the acceptable range? And the answer is, yeah, it's in the acceptable range. So no, this one's not an outlier. So is it an outlier? No, because it still falls in the acceptable range. 43 is just inside that acceptable range. If it was 44, then we would consider an outlier. Okay? What value could replace the lowest value to be considered an outlier? Well, anything below the negative 16.5. So negative 17 would be an example of something that could replace that. Or maybe like negative 17.5 or negative 18. All right, so the best way to state is just say, well, any value, so if x is the value, any value that's less than a negative 16.5. And notice it doesn't say less than or equal to. Negative 16.5 is still part of the acceptable range. Once we go below that, we'll be outside the acceptable range. Okay, so it's really not a difficult thing to do. Interquartile range times 1.5. And then that tells me how far up I'm allowed to go from the third quartile. It tells me how far down I'm allowed to go from the first quartile. Anything in between those values is acceptable. Anything outside those values would be considered an outlier. Okay?